You probably wouldn't want Jerry Tiller's job.
Hello, it's Jerry.
As the general plant manager of the Pueblo Chemical Agent Destruction Pilot Plant, or PCAP, Jerry will take a one-of-a-kind facility in Colorado and prepare it to destroy 2,600 tons of chemical weapons. He and his team will plan the operating procedures, train the workforce, and make sure all the equipment works.
Basically, we're going to be checking the wiring harnesses and stuff like that.
Test the components, the switches.
Basically check that all the transformers and stuff are set up.
Proximity sensors.
You know, the old on-off switch, right?
Fire extinguishers.
We've got pneumatic operated control valves that will make sure switch back and forth like they're supposed to.
Pumps, the motors, all that.
You guys going to be busy?
We're going to be significantly busy.
It's a process called systemization.
The systemization phase for the project has one specific goal, and that's to prepare the facility to move into chemical weapons destruction operations.
Systemization is basically a preparatory phase, making sure that PCAP's people, procedures, and equipment are ready to go before chemical weapons are introduced into the system. And while it's going on in Colorado, it's also beginning here in the bluegrass region of Kentucky, where another plant is being built to destroy 523 tons of chemical weapons stored at the Bluegrass Army Depot.
We have found that if you test out the equipment, you verify the people are ready to go, you verify your procedures are ready to go, you're more apt to be successful in operations.
Our experience tells us that we want to get ahead of the curve. We want to have procedures in place. We want to have personnel training. We have lessons learned with respect to how we've operated other plants that we're incorporating into the design of this facility.
Both the sites in Colorado and Kentucky are still under construction, but while construction is going on, systemization teams are actually on the ground preparing the sites for when they'll begin chemical weapons destruction. So you might ask yourself, how can systemization teams test a site if it hasn't been built yet?
It's actually a waterfall approach, and as construction completes various subsystems, they have the latitude to begin turning those over to us.
Each system is broken down into subsystems. But the first step in our process, of course, after construction is complete, is to receive turnover from the construction organization.
Right next to us here is a utility building. It's one of the first buildings we'll get. We're going to use those utility system subsystems to validate the compressors run, that the boilers come up.
And this waterfall approach means the systemization team receives equipment piecemeal from construction. This is part of the reason why systemization is projected to last as long as it will, especially at Bluegrass, where the construction phase will be a little longer than at Pueblo. This phased turnover provides some advantages to the systemization team.
We have construction on site that can help us out on issues that we come across, and we need some expertise on that they can provide us.
But systemization is more than just testing of equipment, and the tests aren't the only thing going on right now.
Well, the fact is, systemization is a very rigorous, systematic process to ensure that the equipment is properly prepared, the procedures are properly prepared, the people are properly prepared, and along the way, we don't break any equipment, we don't hurt any people.
At both Bluegrass and Pueblo, they divide the systemization phase into three major steps: paper, plant, and people. And when they say paper, what they're talking about is paper. Lots and lots of paper.
You know, we've got probably 10 to 13,000 documents that we're preparing.
Documents that are prepared include standing operating procedures, preventive maintenance instructions, as well as the testing procedures that we're going to use to test the equipment and the plant at the end of the day.
We want to make sure that we've documented and we're complying with laws, regulations.
Then there's the plant phase, testing not only the systems and facilities, but also the software that runs them.
The software nowadays controls everything, and what we're here to do is test out that concept that this software will properly operate that piece of equipment, whatever it may be. And we'll go through systematically from the smallest component to the subsystems to the system level.
What the startup team will do, they'll do an integrated test to make sure that the whole system works, and as part of that integrated test, they'll validate the standing operating procedure, will validate the preventive maintenance activities, the job plans, and so forth.
The last phase, and probably the most important one, is the people phase. That's hiring and training the workforce that will run the plant during chemical weapons destruction.
Well, that's really a big part of startup that most people don't relate to because they think equipment testing.
Our ability to start up the machines and make them work is, in a lot of ways, going to be less of a challenge.
So the latter phases of systemization we kind of call optimization, and that's pretty much the last period of the phase where the startup testing's been done, your procedures have been validated. Now you got to get your people trained.
Once we get past preparation, we move into what we call a demonstration type mode. And what we do there is we actually demonstrate through operational readiness reviews, integrated demonstrations, those types of things, how the workforce can actually handle and how the plant can handle the operations phase that's in front of us.
At the end of that, the systems contractor, if they're confident and feel good about the results, they will come to the government, come to the field office, and request permission to begin agent destruction. At that time, the field office will review what's presented, and then we will endorse the start of agent operations up to headquarters.
So there's all this planning, all this training, and all this preparation going into the systemization phase, but it's actually not going to go well. And that's a good thing.
Systemization without any problems is probably a problem in and of itself, in that what we've designed that process to do is to flush out any issues we might have, whether it be with equipment or systems or procedures.
The real issue is you're trying to get the workforce trained also. So if they have the ability to do some troubleshooting and basic understanding of how a system could fail and how we go in there and actually troubleshoot it and solve the problem, that's great for us.
So just to make sure everyone's calibrated, you know.
It's okay to admit it, systemization probably doesn't sound like that much fun. Unless you're one of these folks.
It's the most fun we'll probably have on this project. If everything come out here and everything worked perfectly the first time, then what's going to happen is, I don't want to say that's boring, but the challenge associated with something not working right is to figure out what's wrong with it and then fix it. And come on, that's fun.
And then it's fulfilling because at the end you really get to kind of see how you took all this stuff, this complex facility, and it's really kind of running as an integrated plant now.
The ultimate satisfaction for systemization is when we know we brought that first munition into the facility and we started the destruction process. That's when we know that systemization was successful.